This lesson goes with Roman numeral 3D in the Honors Chemistry Notes packets. Hopefully by now you are very comfortable with writing the electron dot structures for both ionic and covalent compounds. A lot of times it's not quite as simple as what we've been doing for the basic structures. For example, in letter D, not all covalent compounds have one central atom like the examples that we have done so far in class. A common example is the hydrocarbons. Hydrocarbons are molecules made up of long chains of carbon with other atoms arranged around the chain. Most commonly, this will be hydrogen, as you'll see in the examples. C2H6 is an example of a hydrocarbon. This is called ethane. Ethane is used to make ethylene, a more complex molecule, which is used to make things such as plastics and fertilizers. So we're going to draw the structure for ethane. When we draw a hydrocarbon, we first want to draw out the carbon chain. So there's two carbons in ethane, so we're going to draw the two carbons with a single covalent bond between them. Remember, single covalent bond is dot to dot. It's a line, so two electrons are being shared here, or a single pair of electrons. So remember, carbon has 4 valence electrons and it needs to share 4 times. After you've drawn out your carbon chain, count how many hydrogen atoms would be required to give each carbon a total of 4 bonds. So in this case, if I wanted to give each of these two carbons 4 total bonds, they each start with 1 bond. This one, now I'm adding 2, 3, 4, and the other one started with 1, 2, 3, 4. So notice what I really need to fill these carbons is 6 hydrogens. So now I'm going to ask, do I need any extra bonds, or do I already have enough hydrogens to fill up what will fill carbon up? Well, I said I needed 6 more bonds for carbon, and my formula says C2H6, so I should be good to go, and I'll just add a hydrogen for each place. Now, if I needed to, I would add extra bonds first, and then I would add hydrogens where I needed. But because this is perfectly matched up so that the 6 hydrogens will fill those 2 carbons, I'm finished at this point. How about for C5H12? Let's follow those same steps. First, let's draw our carbon chain. This time there's 5. Let's count how many hydrogens would be needed. You might want to pause and count this one for yourself. So it would need 12. Are there any extra bonds required? No. The 12 hydrogens go around, and this is a complete molecule. What about C3H4? Here's my carbon chain. How many hydrogens? Try it for yourself first. So I have 1, 2, 3, 4, 5, 6, 7, 8. Well, I only have 4 in this equation, so this time I'm not going to have enough. I'm going to come back here to step 3, determine if any extra bonds are required and how many. So this is how I know how many. I take the number of bonds I need, I subtract the number of hydrogens that were found in the formula, and I divide by 2. So I said I needed 8 minus the 4 in the formula, so 8 minus 4 is 4. Because we're talking about bonding between 2 carbons, I'm eliminating 2 bonds, so that's why I divide by 2. So 4 divided by 2 is 2. So I needed to add 2 extra bonds. Now I can add those anywhere. I could add 2 here, I could add 2 here, or I could add 1 in each place. Any of these really is going to be okay. Let's try adding 1 to each side. Well, now we have extra bonds because this one has 1, 2, 3, 4, 5, and so does this. Actually, this one has 1, 2, 3, 4, 5, 6. And this one has 1, 2, 3, 4, 5. So now there's too many. So we just added these ones in red because those are the extra carbons that we needed. So we'll eliminate some of the hydrogens that we thought we needed. Okay, so if this carbon now has 5, let's get rid of one. Let's go ahead and just erase one off. And if this carbon has 4 just carbon-carbon bonds, obviously these aren't needed. And then if this carbon has 5, again, let's go ahead and get rid of one of them. And now each carbon is going to have 4. So I'm ready to go ahead and add my hydrogens. And as you can see, I've only had to use 4 hydrogens now, just like the equation said. And the way that I was able to do that was I had to add extra bonds between my carbons. Now likewise, what if I would have done this? What if I would have said, okay, I'm going to put 3 bonds here, a triple bond, and I'm not going to add any here because I needed to add only 2 extras. So now where could we eliminate? Well, we've got 5, 6 on this one. So let's go ahead and get rid of a couple of those. This one has 4, just carbon to carbon. So let's get rid of those. And this one is good as it is. Let's go ahead and put our hydrogens in. And again, we have just another structure. So this one as well as this one are really the same thing. They're actually called resonance structures because they're arranged a little differently, but that's okay. We just needed to make sure that we were drawing something that had the 3 carbons with the 4 hydrogens and that the octet rule was fulfilled for each carbon.